Hello everyone and welcome to my another video. So today in this tutorial we're gonna learn basically the opposite that we have learned in the previous tutorial. So let me just recap to you guys what we have covered in the previous tutorial. So we covered on a factor into the platform. I will put a link to my previous tutorial on the video in the description below. So basically when you start our game, all the platforms colliders are disabled, the plunk of the platforms, because we want to walk over, so when you jump, the collider are enabled and then we can walk into the platform. So today we're going to learn how we can just drop off from the platform, press arrow key, down arrow key or S key or any key you want to press. So for example, if I press my S key now, I'm gonna release from the platform. So we're gonna learn how to do this in a simple manner using raycasts. And let's jump into the tutorial, guys, and I see you guys on the other side. So guys, if you have watched my previous tutorial, you're gonna be familiar with this script that I have here, platform OwnWay. And I'm gonna reuse it. I'm gonna apply this logic into this script already, so we can have both functionality working. And you may need it in your game as well. So you can jump, and then you can release the character pressing a key, or you can do whatever you want, or any key you want. So it's up to you. I'm just gonna give a brief how you can achieve this, and then you can use your creativity and you can improve it, and you can do so many things after this. So as usual, let's go to Paint and try to draw this, what we want to do. So we have our platform here and we're gonna have our player here. So as I said, we're gonna use raycast, but for performance issue, I'm not gonna be raycasting a line downwards all the time. So it doesn't make sense. It's a waste of processing power, stuff like that, because it's physics. Even if it's 2D, but it's physics. And yeah, you may be asking, oh, but you have only one cartridge and one platform. Yes, I do, but you can have a big scenario. You can have thousands of platforms. You can have enemies. You can have physics in the other part of the game. So it's always good to have a good practice, and especially when it comes to performance. If you are developing for mobile, especially. So yeah, let me try to explain this. So we're not going to raycasting all the time. So we have our player here, and then our goal is to, when the player is on the platform, we shoot a ray. All right, we shoot a ray, and the ray is going to be looking for a layer mask. So if the layer mask doesn't match what we're looking for, so the key press is not gonna work. So we need a layer. We need a layer mask here in this platform, because you're gonna shoot a raycast, and the raycast is gonna be looking for the layer. So if you find it, the hit was succeed, and then we can do all the logic that we want. So let's get back to Unity now, because we need to create a layer. So you just click on the platform, add layer. Let's call, I don't know, platform add. Try to keep capital as default. So it's always try to follow Unity practice, so we're not gonna have a problem in the future. Yeah, press enter. The layer is created. So now let's go back to the script that we have before. I made an improvement, guys. So I'm calling the enable OwnWay function, which is this one, on fixed update, because when you work with physics, it's the best, not the best, but I mean it's better if you call on the fixed update function, because it calls every 30 frame. So you can have a read on Unity website. They have a documentation for fixed update, and they recommend to any physics that we work on, call on the fixed update. So I made this improvement. You guys can do it as well. That's how we do, like, that's part of the programming. You always have to improve your code and clean your code, and somehow you find another logic better than one that you had before, and then you need to apply the best logic that you found later. That's how you're gonna learn and improve it. So yeah. So as I said, we need a layer mask to detect the line, the raycast line, and we need to declare some variables here. So I'm just gonna use a private at the moment. Private. Let me just zoom in a bit so you guys can see, right? Private int, because layer mask, if you guys notice, is an integer number there. You can see like 0, 1, 2, 3, 4. So layer mask. Okay, so let's initialize this variable now on my initialize variables. So layer mask is gonna be equals to layer mask dot get guys. There's a get parameters that we call here in the layer mask. If you guys are in doubt, you can just go to the Unity website documentation. They explain what is a name to layer, layer to name, get mask. So I'm using this because I think it's simple to understand. We are getting the mask, and it says here that we need a string, if you guys notice. So if you hover string layer names. So given a set of layer names are defined by either a built-in or user layer in the blah blah blah. So we need the name of the layer. So that's basically what it's saying. So we get mask, and then we give a string and the name of our layer that we just created. Platform add. Okay, so we already have our layer. So when you're calculating a vector or direction or raycast and in a 2D game, we need to use a vector 2D, which is y and x. So we need a vector to where, for example, we're gonna raycast a line, right? So we have 4 directions: up, down, left, and right. So in our case, as I showed you in a drawing, we're going to cast a line downward. So it's a direction using a vector too. So I'm gonna show you guys. For example, here. Yeah, okay. So this is a 2D vector, for example. This is y. Oh, this is so ugly. This is y, and this is x. So that's how 2D game works, right? If you want to jump, you increase the y value, add force on y value, and if you want to walk, you increase force in x value. So, but you guys need to make sure this right side here, it's positive values, all right, and one up here is positive values. So here is negative values, and here is negative values. So for example, we have a bunch of line like this. I really need to practice my drawings because yeah, okay. So let's make this right here. So we have like 1, 2, 3, and then you have like 1, 2, and then you have -1, -2. So we have -1, -2. So you get the idea. So what is in the left side is negative value. When is on downside is a negative value. Okay. So as you need a vector, let's create a private vector2, which is just y and x. We don't need a vector3 because we are working on 2D game, which only requires y and x. So let's call direction, right? Yeah, direction. Okay, so let's initialize this variable here. So oh damn it. So direction is gonna take we're gonna assign a value of a vector, and which way you want. We want downwards, right? So we can say vector to dot down. We have down. So he's saying shorthand for writing -1 on the y-axis. So basically we are saying that we want this value here to be assigned, -1. So on the y-axis, of course. So down, or if you can do like this, up, and then you can just put negative value. Is the same thing. You put a negative value, subtraction sign is negative. So what is negative in the graph is negative on y is going to be negative value. It's automatically going to get a negative value. So, but we don't need to do that because we just can say down. It's easier to understand. So, okay, you have our direction already. And now we're going to create a function to to shoot a raycast, to shoot a line that we want to shoot, right? So this function is not going to return nothing. So that void means it's not going to have a return. So let's call this shoot ray. Okay. And then we need to declare a raycast variable. So for example, we need to say raycast hit 2D, because we're working on 2D, remember to put 2D, and then the name of the variable. So let's call it hit, and then we need to pass the origin of the raycast, where we want to start shooting from, the direction to shoot, the length of the line, and the color. Not the color, sorry, that's for debugging, and for the layer mask. So we gonna say physics 2D dot, oh my god, no box cast, raycast. We're gonna now, so if you hover here, it's gonna be requiring origin, oh here, come on, yeah, origin, a direction, float is the distance, which is the length of the line, the layer mask, and there's overloaded 6 more options. So this function has some overloads, which means they have other functions with the same name, raycast, but with different parameters on it. So the origin is gonna be the player base, because we want to raycast from the player base, right? Dot position. So we're gonna using the direction, right? Direction, because we created a vector to downwards, and we're going to say 0.5, 0.3 I think is enough. The distance of the line, the length of the line, and then we need to give a layer mask, which we created up there, the layer mask, and then we have our variable hit casting, having all this information. So our variable hit have all this information here. So where to shoot, the direction to shoot, the length of the line that's going to be shooted, and the layer mask, to looking for the layer mask number, not to be shooter, sorry, to be shot. So now we need to create okay, so let's create a debug here so we can see the line, because we need to I need to create a debug to see the line, debug.draw line, sorry, not line, it's gonna be ray, draw ray, and then we need to use the same, what is it saying here? Draw ray, yeah. We need to use the same parameters that we pass in here, because that's only for the debugging purpose. It doesn't affect the raycast in nothing. So you can visualize where the line has been displayed. So player base position, the direction. Now we just need the color, because the color is gonna be let's say red. So just to demonstrate to you guys, I'm gonna call this on the fix update shoot ray, so you guys can see what I'm talking about. Let's play. Let me just untick this. So okay, it's gonna be casting a line. You guys can see casting a line on a fixed update, but we only want to the line to be casted if you're on the platform. So let's go back and you see that. So we need to create a logic here. If hit is true, so if the line hit the layer mask we are looking for, is going to be true, and then we do something here. For example, we can say we hit the platform. Okay, so this, guys, this if hit means is the same thing of this. Okay, it's the same thing. You don't need to put this unless you want to use it. It's up to you. But if there is nothing, means it's true already. Or if for false, for example, you can do this, or you can use a negation, which is this. It's the same thing. It's false. If it's not hit, it's the same thing. If hit is false, it's the same thing. So just for you guys to understand. So we are shooting a ray on a fixed update. As long as you're gonna jump into the platform, you're gonna see this message. Let's go back there, and then our platform needs to have the layer, of course, platform edge, yes. So let's try now and see what we get in the console. So you see, we hit the platform. So it's working, the logic is working, okay? So now let's change a bit of the code, and then we gonna be able to call it only when you are under the platform. So yeah, now let's think about it here. We have a logic already. If the position of our player is greater than the surface of the platform, we enable the collider, right? Great. That means we are on the platform already. So what we can do is we can just call this function shoot ray when this logic here is met. For example, if you are on top of the platform, shoot the ray. So that's simple, okay? And for disabling the collider is pretty simple as well. So let's use input, okay? If input get key code, let's use the S, and we disable the collider. Okay, so let's see if it works, and let's see if it's only shooting the ray only when we are on the platform. So let's go back and let's clear this and let's try. So no ray cast here, nothing has been casting, like no line, you guys can see. And when you jump, hey, there we go, here's the line, and we hit the platform. So we are saving processing power here because it's physics. And remember, this function on enable way has been called on fixed update. So that's perfect. And now if you press S, ta-da, we jump we jump off from the platform. We basically, okay, and if you jump again, so you guys can see it's working perfectly fine. So thank you very much, guys, for watching, and I hope you guys enjoyed and learn from it, because and you guys can improve it. You guys can improve the code and do better with this. That's just the foundation of it, and how you can do good stuff with Raycast. So we can delete this. Always remember to clean the code all the time. So we don't need to debug anymore, because we know already it's working. Okay. So yeah, that's pretty much it. Thank you guys. See you guys next time.